Okay, we are looking at inverses of functions now. We're doing a lot of groundwork to get into logs. So this is part of the groundwork. So inverses of functions. Inverses are opposites. So let's get in. You've seen the word inverse used in various ways. Okay, back in pre-algebra and algebra 1, we talked about additive inverse. If you have a 3, the additive inverse is -3. So basically, if you have x plus 3, to do the inverse of that, you would do -3. Okay, the multiplicative inverse of 5 is 1/5. If you have 5x, to get rid of that 5, you could multiply it by 1/5. You're doing the opposite of it. And a matrix, which we aren't going to get into that. We did that a few chapters ago. When the relation is also a function, you can write the inverse of the function f of x as f to the -1x. This is how we notate inverse, but it does not indicate reciprocal. You remember if you had 2 to the -1, that would be 1/2. Okay, that is not what this indicates. Functions that undo each other are inverse functions. Really basic example here. If you have the function equals, let's just say, x plus 6. If I input x equals 3 in for x, my output would be 9. Okay, the inverse function of that is x minus 6, because if I input that 9, I get out 3. See how it's just everything has come full circle. So to find the inverse function, use the inverse operation. In the example above, 6 is added to x and f of x, so 6 is subtracted to find f of 1 of x, and that's how you say it, f of 1 of x. You can also find the inverse function by writing the original function with x and y switched, and then solving for y. And this is how we are going to work them all. So, use inverse operations to write the inverse f of x equals x minus 1/2 if possible. Method 1. We're just going to do the inverse operation. The opposite of x minus 1/2 is x plus 1/2. Okay, method 2, and this is what we're going to use for the harder one, so we're just going to start practicing it now. F of x is the same as y, x minus 1/2. We're going to switch the x and the y. So we're just, instead of y, we're going to write x. Instead of x, we're going to write y. And then we're going to solve for y. And we're going into basic algebra 1, solving for variables. And we have y equals x plus 1/2. So to write it correctly, you write f to the -1 of x equals x plus 1/2. Yes, we get the same answer. I'm just getting you into the habit of switching your x's and y's. Use the inverse operation to write the inverse of f of x equals x over 3. Okay, the 3 is currently in division mode, so the opposite of division is multiplication. So if you can do that, then that's great. There's your answer. Again, I'm going to switch my x and y. F of x is the same as y, so y equals x over 3, which changes into x equals y over 3. I'm going to solve for y. Multiply 3 by both sides. I'm left with 3x equals y, so f to the -1 of x equals 3x. No, you do not have to do these problems 2 times. I'm just showing you both methods. Use the inverse operation to write the inverse of f of x. It's a you try, so push pause. 2 different methods. That should be subtraction, sorry. Same answer. Undo operations in the opposite order of the order of operations. Okay, it used to be PEMDAS. PEMDAS. Okay, reverse. Sorry, that's the right order. Reverse. Okay, I have a hard time doing the reverse order of operations to figure out the inverses, so the trade the x and y variables works every time. So that's how I'm going to do all of these. It's fail-safe, if that makes sense. You can also find, this is the same slide as before. This is how I'm going to do all the problems. Okay, use the inverse operations to write the inverse of f of x equals 3 times x minus 7. So that's the same as y equals 3x minus 7. I'm going to trade those variables. Now you're going to want to distribute now because we do that a lot currently. And that works. I'm going to go ahead and divide both sides by 3 first because it sort of saves the step. So I have x over 3 equals y minus 7. Then add 7 to both sides. Gets rid of those, and I have y equals x over 3 plus 7. Let me write that the right way. Sorry, I tend to switch things around quickly. I have x over 3 plus 7 equals y. So I can write my answer, f to the negative 1 of x equals x over 3 plus 7. Okay, let's try another one. Y equals 5x minus 7. Trade the variables. X equals 5y minus 7. And solve for y. Add 7 to both sides. X plus 7 equals 5y. Now I need to get that y by itself by dividing everything by 5. I'm left with x plus 7 over 5 equals y. So I write my answer. F to the negative 1 of x equals x plus 7 over 5. Now if I'm going too fast, the great thing about videos is you can rewind and watch it again. Anytime you need to undo an operation or work backward from a result to the original input, you can apply inverse functions. So now we're going to try some real-world problems. In a real-world situation, you don't switch the variables because they are named for specific quantities. So we're just going to solve it for the other variable. Juan buys a CD online for 20% off the list price. He has to pay $2.50 for shipping. The total charge is $13.70. What is the list price of the CD? Now the hardest part about these problems is writing the equation for the total charge. So the total charge is going to be 20% off. So in essence, he's paying 80% of list price plus the shipping charge. That's wrong. Sorry. The shipping charge. Okay, there's your equation. Find the inverse function that models the list price as a function of the charge. As a function of this should be charge. So I'm going to solve for L. So I get C minus 250. I subtract 250 from both sides. Equals 0.8 L. Then I need to divide everything by 0.8. I think I have a blank slide. Yep, let me just write the answer again. I have L equals C minus 250 over 0.8. That's from the previous slide. So we're going to evaluate this function for C equals 1370. Minus 250 divided by 0.8. Get out your handy dandy calculator, crunch some numbers, and I am left with this list price being $14. Let's try. Okay, you try this one. To make tea, use 1/6 of a teaspoon of tea per ounce of water plus a teaspoon for the pot. Use the inverse to find the number of ounces of water needed if 7 teaspoons of tea are used. Hardest part, write an equation for the number of ounces of water needed. So we're using 1/6 of a teaspoon per ounce of water. I can't use an O because that's confusing, so let's use an N for ounces of water. Okay, so 1/6 of a teaspoon of tea per ounce of water plus a teaspoon for the pot. And that equals our T. So the inverse, subtract 1 from both sides. T minus 1 equals 1/6 N. I'm going to multiply both sides by 6 because that cancels that out. And I'm left with N equals 6 times t minus 1. That was a hard one to solve for, but you guys got it. Next page. N equals 6 times t minus 1. Evaluate for t equals 7. 6 times 7 minus 1. The number of ounces is 36 ounces of water should be added. That's all I got for today.